Hey everybody, my name is Scott Sutherland. I am a Senior Director at NetSpy. I currently oversee infrastructure penetration testing and adversary simulation. Penetration testing seems pretty straightforward when you're thinking about internal and external facing networks. Adversary simulation is ambiguous to some folks, so I'll just outline it very quickly. Essentially, me and my team work with blue teams to help them refine different defensive controls through adversary exercises. So through those experiences, I've been able to see hundreds and hundreds of environments over the years, almost 20 years. I'm coming up with the better part of 20 years in information security. And I've seen a lot of offensive trends. I've seen a lot of defensive trends. I've seen a lot of problems solved with software over that 20-year period. But one that I have not seen solved is just share permission management. It's something that identity and access management was supposed to solve, but really didn't very well. And as a result, we still see to this day on almost every internal penetration test we do, excessive shares that give us access to data we shouldn't have, give us access to application functionality, and system access we shouldn't have, right? And this is a struggle that a lot of companies deal with. Almost every company deals with. And most of those companies are starting to try to find new solutions. And most of those solutions currently involve moving to the cloud, which I think is great, right? You have more availability, you have more refined access control, which is easier to manage. But that migration is going to take a little bit of time. And some companies are ahead of the curve. They might have it done in the next few years. Some companies, it will be the 5-year mark. And some companies may never get it done, right? I kind of think about shares kind of like I do mainframes, where in some cases they're running core business, they're used to run core business functions, and it takes a long time to get them off of those platforms and into new ones. So it's a problem we're going to be dealing with for a while, and that's why I put this together, right? Just to bring some awareness to the issue and how to deal with it. So at a high level, what we're going to be talking about today are the problems that kind of arise, right? How do all of these share permissions end up all over our networks in the first place? I'm going to give a brief primer on how share permissions work so you can understand some of the gotchas that go unnoticed. We'll talk about how our attackers actually abusing this. So for those of you who have never been a penetration tester and want to better understand what are the risks or what is the impact associated with these excessive share permissions, you'll get a better understanding at that point. And then we'll cover share remediation and prioritization. The goal is to give you some basic data analytics tools that can help you expedite some of your share remediation. And then at the end, I'm going to share a free tool that I produce called Power Hunt Shares that wraps around some open source tools within the industry that you can use to get a jump start in case you might not have a large budget or a big staff to start chipping away at this problem. So with a lot of my presentations, what I like to do is kind of take a quick retrospective, right? How do we get to where we are today? How do companies have hundreds of thousands of shares with excessive permissions on them, right? That's a lot to deal with. Is it negligence, right? Is it malicious intent? And here I want to just kind of walk through how we get to that point. So that's how we get to meet Jane. Jane is a small business owner, right? Let's just pretend she started her own business. She's wildly successful on her own, very happy chirping along. And, she works with clients over email, but has no real need for any type of file share that's on a network at this point. This point being sometime in 1999. Over time, she expands. She needs someone to help manage finances, someone to help with client relations, and so she hires, Tom. And her and Tom share files via email, and that works fine. It's a little bit messy, but not horrible. Over time, they, decide to hire a dedicated sales and marketing person, a little bit more tech savvy than the other two. And so they create a share, and they say, hey, look, guys, we can organize all of our data here. We're going to be way better off than we were before. And so Jane's super excited about this, and so is Tom. So they start using their first file share. And as their business continues to succeed, they hire more people, and lo and behold, there's another tech-savvy person that joins the fold. They also create their own shares, and now we have 2 file shares on people's systems where they can centralize some of the files that are being used. And even Jane gets excited. She goes out and she Googles how to create a network share so that she can share her own folders with everyone in the organization. And she thinks that's super nifty, but naturally she forgets about it like 2 days later, never to be looked at again. Now, like all small businesses, you grow, and at some point, having all this ad hoc file management just isn't working. So Jane hires an IT admin, and back in the day, the 90s, early 2000s, the big thing to do pre-cloud was to start up a small business server, which was basically Active Directory. So now you can have all these users pulling down information and uploading information to a single share on a single file server, and as an added bonus, you get that controlled by central authentication, central access control, which is Active Directory. And that is great, except for the fact that all of those legacy shares that were created, everybody forgot about, but they're still there, right? There's still exposure sitting there. So this is the beginning of this story. As it progresses, the IT manager has to start creating laptops for all the employees. And at this point, it does go beyond the 4 we see on the screen, right? There are hundreds of employees now, and it's too time consuming for the IT manager to create those laptops for everyone, right? To lay down the software, install the software, get all the settings perfect. And so what the IT manager does is they create a gold image. And this gold image has a standard set of configurations. And sometimes what the IT managers will do is they will set up a share, its own network share, so that they can easily access the system, and they can push patches, manage configurations, and all those other things. But effectively what this means is every employee moving forward now gets this laptop that has this new share on it, right? So this is kind of ubiquitous exposure moving forward from this point. Naturally, the IT manager is not the only role that's a little bit more advanced in IT. Eventually, you're going to get a DevOps person or developer who's developing the websites, the mobile apps, and there'll be a backend database, and both the code for the application as well as the backend database are going to be backed up, and very often that goes to a local share. So this this starts our profile, right? And then unfortunately, we had Tom. He was great, but over time, ultimately he moved on. We can't work with people forever, as sad as that is. He found a better opportunity, and his laptop was left. And Jane misses Tom and would love to recycle his laptop, but she's not sure if there are documents that she's going to need. So she just leaves his system on and leaves the share up so she can go rummage through his files as she needs them, right? So at this point, we have no formal owner of that device. Now, all of these shares in the environment aren't implicitly bad, but they might actually have excessive privileges. Many of them, as we have seen as pen testers, have excessive privileges. And while all the employees might be operating in a very honest way, if an attacker is able to compromise any user, they are going to immediately go and look for this type of access so that they can get data, which they'll then steal and sell on the internet or extort you for. And the newer trend as well is even if they don't get domain administrative access, even if they don't take over the entire network, they're going to try to encrypt as much data as they can and basically hold the encryption keys hostage until you pay them money. And that's right, ransomware attacks. So Jane falls victim to this scenario. She's worked really hard, and she considered not paying the ransom, but determined ultimately that she couldn't recover from it without the keys. So she pays the ransom. They clean up their environment. They're very healthy. She gets back on track. And you would hope that that was done, but unfortunately, share management, privilege management it's a reoccurring task. It's a maintenance and hygiene task, right? And so we can kind of see over time, DevOps guy is playing around and accidentally or intentfully opens up another share. But it's definitely at a smaller scale than it was before. But, as time goes on, Jane's business does what a lot of businesses do. They grow, and grow, and at some point they acquire another business. And this business has not gone through a ransomware attack yet, and they still have a lot of the old issues that Jane's company has gone through. And because Jane's trying to go so quickly, she might buy another company and another company, and all of them have these problems. And so at this point, Jane's parent company is inheriting all of this, what you might call kind of share-related risk. And this is the frame, right? This is the scenario that most companies are dealing with today. This is the starting point. This is where most of us are at. This is what we commonly see. And most of our clients at this point, when we go through these engagements time after time, are asking, how do I get better share coverage? How do I find these bad shares before the pen tester does, before the ransomware threat actor does, right? How do I do that? And if I can find all these shares, how do I know the difference between one that's risky and one that's not? And then for those big companies, there's the question of, if I can find shares and find the high risk items, how do I prioritize 100,000 or more shares in an environment? And so that's kind of the set of questions we're going to try to answer today, and try to provide some free options to get you started. So let's take a look at the problem first, and a lot of these are going to be intuitive for anyone who's done vulnerability management in the past. You know, the first big problem is that managing shares on scale is really hard. We saw a lot of the problems that Jane faced, a lot of the challenges, right? As she grows, as IT grows, as acquisitions occur, it's very hard to accurately manage your systems, to fully understand where all your computer assets are at all times. And if you have a struggle managing your systems, you're definitely going to have a struggle managing the shares that live on them, right? So that's probably number one. An extension of that is just managing ownership. Some companies have CMDBs, or configuration management databases that have all the applications and systems and etc. In one place, so they can be referenced. But many companies do not. So that can be a big struggle if you're blindly groping the environment to try to understand who owns what assets. The next piece of this puzzle, the next problem, is managing share permissions. It's really hard, right? In some cases, you think you're giving restricted least privilege access, when in fact, due to inherited permissions, you're not, right? You're actually giving access to everyone in the Active Directory domain. So instead of a single user, you might be getting access to 1,000 users, right? So we'll talk about some of the gotchas there. But one thing I'm not going to talk about in any great depth are nested groups. Nested Active Directory groups are a big issue that can contribute to this problem, but there is a great tool set out there to help you find that. There is Bloodhound, which is a really good tool to go check out if you haven't seen it before. The other one is Ping Castle. Both of those will help identify groups with a lot of nested members, which might be providing privileges that you didn't fully understand. Everyone's trying to solve this problem. How should I provide access to shares in a least privilege way? Which shares have excessive privileges? A lot of companies are leaning on vulnerability scanners that just weren't meant for that purpose, right? There's a number of shortcomings with that strategy. The first one is that you're probably not getting full coverage. Most vulnerability scanners are pointed at a subnet or even a static list of servers, and if systems are added in between or since your last scan, you might miss things. The next thing is that many companies aren't performing authenticated scans at all, so they're only seeing what an unauthenticated attacker with a connection to the network would see. But the reality is, right now, most attackers don't get in through physical access, right? They guess a password from the internet and they get in through RDP or Citrix. Or they phish a user, and that user now executes their code, and now the attacker's running on a workstation as an authenticated domain user. That is typically the starting point, and that's not being taken into account very often. The next thing is a lot of the inherited issues, the permissions inheritance that we talked about earlier, those aren't taken into account with vulnerability scanners. And the vulnerability scanners aren't really rolling the data up in a way that makes it contextual to your organization, that allows you to even parse the data cleanly, right? A lot of the output of these scanning tools is very verbose, and it's not very structured, so it's very hard to use. Next in line, as far as what the problems are, I mean, aside from all these issues with trying to manage and evaluate scanners, the shares are really, really easy to exploit, right? SMB shares are one of the most abused attack surfaces that I see on internal penetration tests. I can't tell you a penetration tester that I've talked to that doesn't have at least one war story that includes them taking over an entire environment, starting with a share, right? And then the second piece of that is that this requires the least amount of knowledge. To identify a share and just randomly kind of search through it doesn't require advanced scripting or hacky skills, right? Essentially my grandpa could do it, right? And he's not a very technical guy, right? He can click his way through until he finds your PII. So that's really impactful. So after thinking about this for a while, I came to the conclusion that most vulnerability management programs just overlook high-risk shares altogether. It's kind of broken, right? Or maybe it was never built in to begin with, right? To try to identify this surface of attack and evaluate it sufficiently. So that will lead us kind of into our next section, where we talk about trying to understand share permissions a little bit more so that we can be better at evaluating them, be better at finding high-risk areas. So we'll start with the basic definition of a share. At the end of the day, a share is just a local folder that's made accessible to a remote user. That's it. Start, stop. And access to those shares is controlled at two levels: the file system level through NTFS permissions, and the share level through share permissions, right? There's two gates you have to get through from an access control perspective. And usually it's the most restrictive permissions that win. So let's take a look at what that looks like. So here we have our remote user, John. And John has been awarded full control permissions over the share, right? So that allows him to now evaluate, does he have access on the OS level, right, on the NTFS permissions. And there, John has read access, right? And so because the read access is more restrictive, John only gets read access to those files. Now, inversely, we could take Kevin as an example here. If you look towards the bottom, Kevin only has read access on the share level, but he has full control on the NTFS. Because the share permission is more restrictive, it defaults to the more restrictive setting. So it sounds pretty straightforward, right? But unfortunately, things aren't quite that simple. All right, so the first thing to be aware of as a gotcha when you're assigning permissions is the everyone group, right? It's become actually kind of a best practice or a standard within IT to, at the share level, provide the everyone group with read access or potentially even write access. And the everyone group essentially means everyone, both unauthenticated users as well as authenticated users, right? So even if Stephen isn't on the domain, he can still access the share, right? He can see what files are there and see what's listed. But when Stephen attempts to actually access those files, then the process will include looking at the ACLs on the file itself, and we'll see that Stephen does not have any explicit ACLs here. So ultimately, he'll be able to read the list, but won't get any access, right? So most IT admins are controlling access back here at the operating system level and just allowing, full access to list. However, there are a couple of things that have been causing problems in these scenarios, because most of the time admins are not providing ACL access via individual entries. Most of the time they're using groups, and one of those groups is the built-in users group. This is very plainly the local users group, right? And if an admin assigns this, usually their intent is to only allow local users to access the file, whether it's locally or a local user being used to authenticate from a remote system, right? Like we see here. On a system that's not associated with an Active Directory domain, that's the case. That's what happens. And so here, if local user attempts to access the share, everyone permission applies. They have the ability to then go check their access at NTFS level, and they can see, yes, I'm a local user, so I get read access, which is great, right? But what's interesting is underneath or nested within the built-in users group is the authenticated users, which basically still just means any local user account at this point, right? Because it's not associated with Active Directory. But once you join that system to Active Directory, what happens is domain users gets nested implicitly within the authenticated users group, as does domain computers. And so now at this point, not just the local user has access, but all domain users have access. And this is a privilege inheritance issue that doesn't just affect shares. We spent a lot of time hacking around with SQL Server and had a lot of success on that front as well. So this really could apply to any object in the Windows kind of ecosystem. But it has resulted in a ton of unauthorized access, and it is an inheritance problem that vulnerability scanners don't look for today. All right, so what's the impact, right? What can an attacker do if they scan your environment, they find shares, and they find them with these permissions, right? They find change or write or read permissions assigned explicitly to the everyone group, built-in users, authenticated users, etc. What do they do from there? At a high level, they're going to be looking for data using traditional searching techniques. We've also worked with a few clients who have observed attackers actually modifying data, modifying databases in some cases to approve money transactions. We've seen them changing account numbers. So ultimately, the attacker is getting some money in the real world. But that requires a lot of research, a lot of skill, a lot of time. And so as we've seen, a lot of attackers are kind of resorting to ransomware, which is a little bit more blunt force. But as part of ransomware attacks, they are moving between systems. They want to get as much access as they can so they can wholly encrypt your environment to make sure that they get paid to give you those keys, right, to decrypt your environment. So with access to the shares I have listed here, they've been moving around. Like we've seen this in a number of ransomware attacks, and we've used it quite a bit over the years during real penetration tests and red teams. So I want to walk through this just a little bit at a higher level. I was going to record some demos, but I decided just to go with the diagrams to keep it simple. So in this environment, we have a web server that has a web application hosted on it, right? You can go to the web server via your web browser to view the web page and use the app. And that application stores all of its data in a database, which is on a different server. And the way that it communicates to that backend database is using a set of hard-coded credentials. Not always, but in many cases, we've seen that happen. And so normally, everyone's operating in the environment safely. But if a domain user gets compromised and that attacker decides to start looking through the environment and they find that read access to a web root, storing the source code for the web application, sometimes they're able to actually pull out what's called a connection string. And that connection string includes the database server name, it includes the IP, the port, and it includes the credentials for authenticating to that database server. And so then the attacker can reuse those credentials to compromise the database server. And at this point, not only have they moved laterally, but now they've changed their user context, because that database server service is most likely running under a different user context within the Active Directory domain. So they have data access, they have system access, and now they have a new identity that they can try to reuse to access other systems in the environment. And they can kind of continue to spread from there. So this is a picture of an attack that's only leveraging read access. So even read access to the wrong share can be very impactful. Next, we have write access. And in this scenario, we're going to go with the same architecture. We're going to see that our domain user was compromised again. But in this case, we're going to upload because we have write access. So in this case, we can upload what's called a web shell. This is basically a piece of server-side code that allows us to, think of it like this, extending the capabilities of the web application that's already accessible via your web browser. So we upload this file. We're then able to navigate to the web browser and then execute whatever commands we want on the server itself. And once again, now we've laterally moved from the domain user system to the web server, and we're now probably running in a different user context, and that user may have access to all the web servers for all we know. Might be a server admin, and they can continue to escalate from there. All right, so that's a quick overview. Next, we have a number of different ways to get remote command execution that doesn't involve a web server or a database server that are a little bit more generic. So in this instance, we see the $sign being exposed on, could be any server. It's still labeled as web server, but $sign is a default share that gets installed with Windows, and normally only administrators can access it. But over the years, doing penetration tests, we found that that $sign share is actually exposed in way more environments than you think. You know, like maybe 80% of the environments we touch, we find at least one $sign share that we can interact with. We can either read or we can write. And that means we have full access to the operating system to read and write files, which is pretty crazy. Most of the time when we get back to root cause, it's the result of an app being installed that's configuring the share permissions in ways it really shouldn't. But the net result is now we can read and write. So once an attacker comes into the environment, if they see that $sign share available, they see it as an immediate opportunity to get code execution on the remote system. And the first and most popular way is through DLL hijacking. So when an application loads in Windows, it will load a number of different DLL files, and those DLL files have a bunch of code in them so that the application can function as it needs to. What attackers can do is they can either replace those DLLs or put the DLL in a place on the disk where it's going to get loaded first, right? So they can kind of hijack the application's execution, and now they can arbitrarily run commands on that server or that system through that application's context. There's another technique that's very similar called application domain hijacking, which is awesome. This also actually involves uploading a DLL and a config, but it allows you to hijack execution for any .NET app, which is really neat. If you're a pen tester and you haven't looked at this technique before, you should go check it out. It was something that was popularized by Casey Smith at DerbyCon, I want to say 2 or 3 years ago. So very neat technique. Other lower tech version of this would be all user startup folder. So there is a folder in Windows that when you put an exe or a batch file in it, the second any user logs into the system, it will execute that command in that user's context. So that's another popular option. You can also modify existing scheduled tasks. You can modify service binaries. So off the top of my head, there's at least 5 options there for getting command execution from share access. So that's the type of impact that we're looking at, right? And of course, with write access, you can always encrypt the files, you know, coming back to that ransomware scenario. So how do we deal with all this? How do we find these? How do we remediate these on scale? And what are the challenges, you know? So we think about how are we going to solve this problem and the volume that we're dealing with, right? Because the challenge is one share, if you find it has excessive privileges, it's really easy to remediate. 100, you can manage it. 1,000, it's starting to be a pain, but once you get over 100,000 for big organizations, it's incredibly hard, and it's not the only task most people are doing, right? This is usually something owned by identity and access management, and they own a lot. They have a huge umbrella of responsibility, and they can't all the time dedicate themselves to just this task. So it's a huge thing. But to start solving the problem, you know, when we were thinking about this a while back was, okay, what do we need to know to really streamline this, right? So we started thinking, put on our detective hat, start thinking about the where. Okay, we need to know where the systems are, what their names are, what subnets they're on. That could be helpful. Which ones are high risk, right? Thinking about how to determine that. Who created them? You know, we're going to have to go back to somebody to fix this, and it's not going to be me. When was it created, right? That type of context can be very helpful. What's it associated with, right? Does this share even need to exist? Is it associated with a process that's or application or business unit? And how did it end up in the environment to begin with? So these are all really basic questions that we can ask ourselves to try to start to solve this problem. And so the next thing is, where do we get the information to answer these questions? What are going to be our data sources? And Active Directory is kind of the first piece, right? The where, right? We need to know where the computers are so we can look at their shares. And Active Directory is a great spot to start because most systems are associated with it. And you can get that list of systems as a normal domain user with one simple query, which is excellent, right? The next spot to get this data would be the shares themselves. Once you know where the computers are, you can now start to query the share information and get the owner, get the creation times, get the names of the folders, ACLs, list hashes, etc. And you might also be able to cross-reference that with your configuration management databases, right, to get those owners of all of those, either the systems or the shares themselves. On that last list related to shares, one of the things we're going to be talking about in a little bit is how do we group information logically so we can see which things are significant and which groupings of shares can we remediate at one time, through one action. But another way to do that is to look at list hashes or folder list hashes, which not everyone's familiar with, so I thought I'd dive into this one just a little bit. All right, so here's the basic concept. In this local folder, I have 4 different directories, and 2 of those directories contain the exact same file list, right? Banking and password text files are both there. And so this could indicate that these are both part of the same application or same business process. And so grouping these together is going to be important, right, to streamline some of our remediation efforts. And from looking at this screen, it's very easy to tell these 2 folders have the same files, folders 1 and 3. But in reality, when we're trying to scale this, we're not going to be able to look at all these folders one at a time. We need a better way to quickly compare all of these things. So that's where directory list hashing comes into play. So instead of just looking at these, we're going to take the text representation of the file list and we're going to run it through an MD5 hashing function, which is going to spit out an MD5 value. And so from here, we can now see very cleanly that these have the same hash. So now we can use a single value to compare potentially thousands, hundreds of thousands of directories, right? So that's the general idea behind file hashing. All right, so we have our targets. How are we actually going to collect this data to get us started, right? Like we said, the first place we're going to go is Active Directory. There's a PowerShell commandlet that will allow you to do this, to grab the computers as well as the subnets. There's also a legacy open source offensive security tool called PowerView, put out by Will Schroeder. It's been out for a long time, but still very useful. Functions still work. The LDAP queries are still the same. Also, we want to pull data directly from the shares like we talked about. And so there are some PowerShell functions for that as well. And you can run this as a normal domain user and collect that data remotely, or you can use something like PowerShell remoting to collect all this information as a local admin. All right, quick tips. When you are collecting this data, if you're in a larger organization, make sure that you're including all your Active Directory domains so that you're getting full coverage. Next thing is to verify domain user privileges. Sounds simple, but you just want to make sure that the user can actually authenticate to all the domains you're trying to pull your computer list from. Once you have that computer list, I do suggest doing ping and port scanning to understand what is your connectivity to all of these systems. Because just because you can't connect to them doesn't mean they're not there, right? There might be a firewall separating you from that system, and there might be security exposures on the other side of that firewall. So figure out how to get that information. Sometimes the scanning activity has to take place from different locations on the network. And then start grouping data to answer these questions, right? We now have collected a lot of the, using the commands I just showed you, you're going to be able to have a nice database of information that you can now start to query to get answers. So basic techniques for querying. The first one is very simple. Just searching for known high-risk share names, right? That $, admin $, www root, web root. Those types of things can go a long way. Very simple searches resulting in very high exposure. or the identification of high exposure shares. The next one is to group all of these things logically, which basically means we're going to get a count, right? How many shares are owned by this person? How many shares have the name backup, right? How many subnets or how many shares are on this subnet? How many files? How many ACLs, etc. Lots of ways to group the counts. And those groupings can show you which things are most significant. And the higher the counts, the more likely it is that you're going to be able to remediate some of these issues with a single owner and maybe even a single action, right? You won't have to go through 100,000. Maybe in one grouping, you can cut out 50,000 out of the gate. That's a real thing that we've seen. All right. So next is timeline analysis. Like we said earlier, we're going to be pulling or collecting timestamps or creation time from each of these folders and files. And you can then put those on a timeline and see little clusters of when these things were created, right? So that's can be very useful as well for doing correlation and maybe even causation that can map you to a business unit, app, or owner. When you get to prioritizing triage of these items, right? First thing I recommend, even though every environment's going to be a little bit different, is filtering for ACLs that are assigned to inherited groups, right? Those are those high-risk, low-hanging fruit things we saw earlier, the built-in users group, everyone, domain users, etc. The next one is filter those for high-risk shares, because those are where blood is in the water, right? That's where an attacker can easily get access and turn initial share access into command execution and potentially data access. Next, group by name, right? These are the things that are going to help you understand which shares are most likely associated with a specific application. And then as a backup to that, like we talked about, you can do file list hashing to understand which shares have the exact same contents, right? Once again, those groupings could reflect a shared process or application, etc. And then lastly, also if you do have it, try to cross-reference your configuration management database, right? Try to get those asset owners tied to that set of data. And we've actually had clients who have done this and taken some of the automation we'll share later and streamlined it so tickets are basically created, service tickets are created and sent right off to the owner, which is pretty great. And then you always have more context. Context is king. You're going to know your environment more than anybody else. You're going to know the critical application names. You're going to know the critical owners. And so always try to apply context over, this approach. Now, these aren't perfect, but they will help reduce the effort that's required to actually analyze all the shares and hopefully prioritize, some of the triage. And so from here, I thought it might make sense to just consolidate this a little bit and then just talk about preventative, detective, and corrective measures that can go along with this, right? Or along with that process. The first one is just your standard administrative controls, right? We all love policy, standards, procedures, and change control. They're the best. We're all constantly trying to enforce the least privilege that they imply. But the other thing that you need to remember that some companies forget about is that we should also be trying to reduce our attack surface whenever possible. If something doesn't need to be online, take it offline, right? That's a huge deal. And then as a pen tester who's been in the industry for a long time, I can tell you that isolation will slow me down on the host level, on the network level. So do consider using that as somewhat of a mitigating control because it does make it harder for attackers truly. It's probably one of the most undervalued tools in the toolbox today. All right, so that's some guidance on preventative control measures, pretty cut and dry. Detective control measures is all about monitoring things, right? Being able to identify a bad thing as it's happening. And so first things first, let's identify your critical assets and your critical shares that are storing customer data, HR data, etc., and put monitoring controls on those. Watch for changes in access because most of those folders and files are going to be leveraging the same set of users on a regular basis. And if the attacker coming into the environment doesn't think to impersonate the right user, right, they might try to access one of these shares, and that share access will show up as an anomaly, right? It's not normal for that user to access that share, right? So think about those types of things, you can do that on the cheap. Actually perform your own share reviews, not just annually. Share maintenance is something, share hygiene is something that's real that you have to do on a reoccurring basis. And then, work with your SOC teams to make sure that you can identify share scanning, because as a vulnerability management team or an IAM team, it makes sense for you to do broad share scanning to identify excessive privileges. But it doesn't make sense for everybody else to do it, right? And so if an attacker comes in and starts doing broad scanning, you should be able to identify that via NetFlow data. You should be able to identify that through Windows event IDs that are listed here. I didn't put all the thresholds and correlations, but it should be a good starting point. All right, and then corrective measures, right? If you're identifying all these things, all this excessive share access, all this risk, we want to make sure that it's getting remediated. So these excessive privileges really need to be treated like a vulnerability, right? They need ticket assigned. They should be remediated in accordance with your internal SLAs, right? And business owners will need to understand the impact of that. So those are another thing to consider. All right, and so that brings us to Power Hunt shares. I've taken a lot of the concepts we've talked about today, and I've tried to automate it and turn it into a single button for people, once again, who may not have the budget to buy commercial tools to deal with this. I haven't actually seen a commercial tool that does what this does at this point, but hopefully we'll see the emergence of some of those in the future. So what Power Hunt's going to do for you is our Power Hunt shares is going to go out, it's going to inventory all the computers in your Active Directory environment. It's going to get a list of all the shares. Using the searching techniques we discussed before, it will identify the high-risk shares. And then using the data analysis techniques we talked about, it's going to also provide you some data insights that could help you prioritize remediation. And it comes with a lot of fun output. So you get this HTML report, which is kind of the landing page, but also you'll get a CSV and some other things. So to give you a quick primer on this before I show the video, you can download it from GitHub. It's free. It's out on NetSpy's GitHub account. You can import it like a proper PowerShell module, or you can download and execute it in memory, which is what all the fancy people like to do. So there you go. Once it's loaded, regardless of your method, you can run it from a domain system or a non-domain joined system. Either way is fine. Right, I definitely encourage folks to use the credential option so they don't have to type their password into the command line, which is going to get caught by EDR or at least logged by EDR, right? As defenders, we want to try to follow best practice there, so I've done my best. Next, when you run it, you're going to get this HTML report, which we saw earlier. You'll also get CSV output. So at each phase of discovery, at each phase of analysis, it will output another CSV file. So you can kind of cut that up and use that as you want. You can consume it into an SQL database. You can consume it and analyze it in PowerShell, whatever you like to do. Here's an example of consuming the list of excessive privileges into PowerShell after the scan's been run and being able to filter it however I want, right? You can see the computer name and the IP address and a bunch of other information, right? All right, let's take a look at the demo. So this is what this is going to look like. This is in a small environment, lab environment with only 3 systems that I created. And first we're going to download it into memory. So here, that first command is just letting PowerShell know that I'm okay softening my TLS controls so I can download the script from GitHub. So now it's loaded into memory with the second command. And now I'm going to run invoke hunt SMB shares. And so thing to note, you can get through, with the current threading, you can get through about 2,000 systems an hour with this. So in really big environments, it might take up to 24 hours to run, but I do have the progress bars here, as you can see, so that you can kind of keep track of where you are and it doesn't look like it's just stalling out. At some point, we'd like to rewrite it in C#, but at the moment, we're still using PowerShell v5 run spaces, essentially. So here you can see it's going to generate an output directory that's unique, so you can run it as many times as you want, and it won't squash your old data. It will grab the computers and subnets from Active Directory. It will check connectivity. It will grab the list of shares. based on some predefined criteria, try to understand which ones are excessive. And then it will start to analyze all of that data to generate the HTML and trends that we talked about before, right? So you get a nice little mini console report at the end, but you also get the output directory, like we said. So it has the time stamping on there. And as you dig in, you have a results directory and this HTML report, which I'll bring up. And so from here, you can see a nice landing page that kind of tells you how the scan was done and how to use the report. And the dashboard will show you how many computers were affected, how many shares were affected, ACLs, and what are the top shares for the environment that had excessive privileges. I also have it generate a timeline report, so you can see where the different share creations clustered. You get a nice little snapshot of whether they provide read, write, access, or they're high risk. And then for each of these, you can dig in. For the computer, share, and ACL, you can dig in and get this type of data, right, to understand discovered, non-default, read, write, high risk. And there's a CSV link and an HTML link, like you can see here. Those HTML pages are all static. It's not coming from a database, but I just wanted to make it easier for people to navigate. From here, we can go into data insights. We get to understand, those low-hanging fruit groups, how much exposure is there. We can see what are the most common share names. We can see how many folder groups they have, right? Like we talked about, those hashes, right? There's 2 different directory structures, which tells us each share is a little different, even though they share the same name. Inversely, we have the top folder groups. We can see that there are 2 shares that have the exact same file contents. And we can also answer that where question once again. So the tool goes out to Active Directory and it will cross-reference the IP of the system with what's known in Active Directory and actually try to populate that. There is one shortcoming there right now. The parsing of the subnets does not work very well for IPv6. It's a known bug. But for now, it's still pretty good. And from an output perspective, this is kind of what's in that folder I talked about earlier, right? All these CSVs, the linked HTML. And then I also have at least one file here that will provide all the directory listings for all the shares that were provided. And right now, by default, it only does 3 folders deep, but it can go deeper. It's a configurable option on the tool itself. So that's the gist. That is what this is all about. Hopefully this will help you identify and clean up shares in your environment. If you want to talk about this offline, happy to chat, so please feel free to contact me through whatever means makes sense to you. Also, I just wanted to note that NetSpy is a really fast-growing team. We have lots of great opportunities pretty much at every level in every major discipline, right? So whether you are an application hacker, mobile hacker, hardware hacker, network penetration tester, looking to get into sales within the space, we have a ton of opportunities. And it's not just for people who have been in the industry for a long time, right? We also have the NetSpy U program. So if you're looking for a career switch into security, you're coming out of college and you think security looks really, really fun to get into, and you'd be right. That's what NetSpy U is for, right? It's a paid program for 3 months. You come in and we teach you how to hack. And then we ramp you up into a consulting position. So we have a really great team of teachers who take the time to really give you some one-on-one time to understand how the attack works, how to fix them, and how to operate as a consultant in an enterprise environment with really big clients, right? Because we do work with not just Fortune 1000s, we work with Fortune 5 companies too. So some of the biggest companies in the world. So very exciting opportunities. Hopefully you'll reach out if that's something you think is interesting.